in AP Calculus for section 3.6, which is on the chain rule or derivative of composition functions. So a composition function is when you have functions inside of other functions. It can be written in exact function notation as f of g of x. So you would have one function, the g function, that would be written inside of the f of x function. We're going to look at some examples here in a second so you'll kind of understand more of what I'm talking about when I say that. So the derivative using the chain rule for a composition function is f prime of g of x times g prime of x. Or if you think of it in words, it would be the derivative of the outside function with the inside left alone. Now, this is not a multiplication problem. This would still be the inside composition. So you'll see more of what I'm talking about in a minute. And then we multiply by the derivative of the inside. So, for example, down here, where we have y equals the sine of 7 minus 5x, we have a function within a function. This 7 minus 5x is a function in and of itself. So it's our inside function, or our g function. Sine, then, is our outside function, or our f function. So to find the derivative of it, we would take the derivative of the outside, so that would be sine. The derivative of sine, we learned in the last section, is cosine, with the inside left alone. So I can't just write COS. I have to be taking the cosine of something. Well, in this case, I'm taking the cosine of the same thing I was taking the sine of, so 7 minus 5x. We then multiply that by the derivative of the inside piece. So we focus only on 7 minus 5x then, almost like the sign isn't even there. If you focus only on 7 minus 5x, its derivative is negative 5. So we have cosine of 7 minus 5x times negative 5, or you could write that as negative 5 cosine of 7 minus 5x. That is the derivative of y equals the sine of 7 minus 5x. So the next example we have is very similar. It's the cosine of the square root of 3 times x. Notice a lot of times on these it's easy to identify the inside function because it will be inside the parentheses. Also notice on this particular one that square root radical is only over the 3. The x is not inside of the square root. So if I'm going to do the derivative of it, the outside function is cosine. So the derivative of cosine is negative sine with the inside left alone. So that's of square root of 3 times x. Then we will multiply that. The cosine is essentially gone, and so we will multiply by the derivative of the inside. Square root of 3 is just a constant. So a constant times x, the derivative of it, is just whatever the constant is. So my derivative is y prime equals negative square root of 3 times the sine of square root of 3x. Okay, number 3. Believe it or not, this is a composition function. With that squared right there, it can be sometimes kind of tricky when we have it written on trig functions, so it might be helpful instead to think of it as secant of x quantity squared. Then we can see that the squared exponent is actually the outside function, and then secant of x is our inside function. So when I go to take the derivative of the outside, all I'm doing is taking the derivative of the power. So that would simply be a power rule. We would bring the power in front, keep the inside like it is, and then our new power would be 1 less than our old power. So 2 minus 1 is 1. So you don't even really have to write that 1 there, but I wanted you all to see how the 2 decreases and becomes a 1. We then have to multiply that by the derivative of the inside. So the derivative of secant x, hopefully you remember, is secant x times tangent x. Then it's just a matter of combining the things that we can combine or writing it all together as a multiplication. Notice that I have two secants here that are being multiplied together. So that actually becomes secant squared. It's just like if you had two x's that were being multiplied together. X times x is x squared. Secant times secant is secant squared. And then we have the tangent x written at the end. Notice that the x is still inside of the secant and inside of the tangent. I can't eliminate those from those two different trig functions. All right, so let's back away from trig functions for a minute. We've got y equals 3x squared plus 1 quantity squared. So again, the parentheses make it easy for me to see. This right here is my outside function. This right here is my inside function. So when I'm doing the derivative of the outside, again, just like in the last problem, I'm going to use the power rule. My new exponent would be to the first power. And then I'm going to multiply that by the derivative of the inside. The derivative of 3x squared is 6x. And then the derivative of plus 1 would be a 0. So there's nothing else there. So you can leave your answer written like that with the individual factors if you want. We could also take the 2 and the 6x and multiply them together to give me a 12x times 3x squared plus 1. Or we could distribute everything and get 36x cubed plus 12x. But honestly, this is correct, or this is correct. You can write your final answer any one of those three ways and get full credit. Multiple choice would probably be that last option of 36x cubed plus 12x. But you should be capable of getting from the first step here down to the last step by using distribution if you have to, only if you're trying to find your multiple choice answers. If it was an FRQ, you could have stopped with that very first one that we have written down there. All right, let's take a look at number 5 here. Number 5, hopefully you immediately notice that you do have an inside function. It is inside of the secant function. But then I've also got this x guy here. That's because I have a product going on here. So this is actually a product rule problem, but I'm going to have to use the chain rule for some of the product rule. So hopefully you remember from the product rule, the derivative is the first function. So this right here is my first function. All of this is my second function. So it's my first function, so it would be x, times the derivative of my second function. So here's where the chain rule comes in. The derivative of secant is secant tangent. So it's secant of whatever I had inside to begin with. Tangent of whatever I had inside to begin with. Okay, so that's the derivative of secant, secant tangent. Then we have to multiply that by the derivative of the inside. So the derivative of 3 minus 8x would be negative 8. So all of this right here is the first function. All of this is the derivative of the second function. And then we're going to add to that the second function, finishing off our product rule count. The second function times the derivative of the first. The derivative of x is just 1. Again, if this was an FRQ, you have done the derivative. You can't stop. If you want to clean it up at all of this from the x all the way down to the negative 8 right before that plus sign, that's all one term. Really, the only thing you could do is pull the negative 8 out in front. So this would be more like a coefficient there. And then the second piece, that's just secant of 3 minus 8x. You cannot combine the two different secants that you have here because one of them is all by itself and the other one is attached to the negative 8x and the tangent of 3 minus 8x. So that's as good as that answer is going to get. Okay, let's look at just 2 more here. All right, so here we go, square root function, and I can tell that I have a function inside of my square root. So the square root would be the outside function. 2x squared plus 1 would be the inside function. But we've discussed that when we have radicals, It's usually easier when you're doing the derivative to rewrite that radical as an exponent. Hopefully you remember that a square root function is the same as raising to the 1/2 power. So if I rewrite my y equals like that, that's now just a power rule, chain rule problem, like we've already done back in number 4 there. So I bring my power in front, keep the inside the same, and then remember your exponent becomes 1 less than the original function. So 1/2 minus 1 is negative 1/2. We then have to multiply by the derivative of the inside. So the derivative of 2x squared plus 1 is going to give me 4x. So you can stop. You have found the derivative. You can leave it like that. If you really want to multiply stuff together, the 1/2 and the 4x can multiply to give you 2x. And you would have 2x squared plus 1 to the negative 1/2. Again, you're perfectly fine to stop there. Multiple choice though, since the problem started with radicals, the multiple choice answers are going to finish with radicals on. So the 1/2 would tell me that it needs to be a square root, but since it's a negative 1/2, that means that the square root would be in the denominator of the fraction. So this would definitely be what the multiple choice answer would look like. But again, you could have stopped all the way back here on an FRQ and you would have gotten full credit for that derivative. So now let's look at number 7. Number 7 is basically we've added one more function into the mix from what we had on number 6. So we actually have a function inside of a function inside of another function. So we can think about this even as sine of 2x squared plus 1. I think it doesn't work to the 1/2 power. Okay, so here you notice the outermost function would actually be sine. So when I go to take the derivative of sine is cosine of what I was taking the sine of. So that would be of the square root of 2x squared plus 1. I would then multiply that by the next layer, which would be 2x squared plus 1 to the 1/2. Now, it just so happens that we already did the derivative of 2x squared plus 1/2 back up here in number 6. So I'm just going to write that answer. From number 6 down here as the rest of my chain rule for number 7. So again, I could stop here, I would be done, I would get full credit for my answer. If you put it together all into one fraction, you would have 2x cosine square root 2x squared plus 1 over square root 2x squared plus 1. Let me ask you a question. Could I cancel out those square roots? Think about that. If you think you can, cancel them out and write down what you think the correct answer is and bring it to class with you the next time that I see you. If you don't think they can cancel out, think about why, so that you can defend yourself to me the next time that I see you. And this wraps up the chain rule video.